Hello scholars, this is the last video for this session. This video is all about factoring quadratics. So this presentation is associated with your assignment that is titled Factor Quadratics in our Blackboard. Let me just show you what it looks like. Under week number 2, it should be chapter 1D Factor Quadratics. By the end of this video, you should be able to factor the greatest common factor of a polynomial, factor a trinomial, and factor a trinomial by grouping. So factor the greatest common factor of a polynomial. The greatest common factor, or what we know the GCF of polynomials, is the largest polynomial that divides evenly into the polynomials. The GCF of a polynomials works the same way as fractions. 6x is the GCF of 12x and 18x squared because it is the largest polynomial that divides evenly into both 12x and 18x squared. Given a polynomial expression, we'll factor out the greatest common factor. First, you identify the GCF of the coefficients. Second, you'll identify the GCF of the variables. Third, we will combine to find the GCF of the expression. Fourth, determine what the GCF needs to be multiplied by to obtain each term in the expression. And then write the factored expression as the product of the GCF and the sum of the terms we need to multiply. Let's take a look at our first example. We are asked to find the factor of 5x to the third, y to the third, plus 45x squared, y squared, plus 30x, y. So the GCF, or the greatest common factor of each term of this polynomial, is going to be 5. Why is it 5? It is because that's the largest number, the largest factor that can be divided evenly on each of those coefficients. So if you try, 5 divided by 5 is 1, 45 divided by 5 is 9, and 30 divided by 5 is 6. So that would be our GCF. That's the biggest number that we can use to divide those coefficients evenly. Then the GCF of the variables, it should be the exponent of the lowest degree. So for example, as you can see here, the lowest degree for x is 1, so that could be our GCF in terms of the variable. And also for the y, the lowest degree is y, of the y is 1, so that could be the GCF in terms of the variable. Now once we figure those out, the GCF for the coefficient and the GCF for the variables, we're just gonna combine them together. So basically the GCF of this polynomial is really equivalent to 5xy. This GCF tells us that this is going to be the factor, the expression, or the term that can divide each of the terms here in our polynomial evenly. So once you've found the GCF, that is considered already one factor. But we need to find the other factor as well. So to find the other factor, we're going to use the GCF to divide on each term. And whatever the result is, that is going to be the second factor. Let's go ahead and do that. So I'm just going to rewrite our original polynomial, which is 5x to the third, y to the third, plus 45 x squared, y squared, plus 30xy. Now I'm going to use the GCF to divide on each term. I'm going to divide the 5x to the third, y to the third with 5xy. So keeping in mind that if you don't see an exponent on our variable, that means there's automatically an invisible one. So same thing here, we're going to do 5x to the first and y to the first. And also in our last term, gonna divide it by 5x to the first, y to the first. Now to identify our other factor for this polynomial, we are going to apply our knowledge in the rules of the exponents. So as you can see here, we have the fraction bar. If you remember, I told you on the second session, if we see a fraction bar, that means we're going to subtract our exponents. So let's take care of first of the coefficient. So 5 divided by 5, that gives us 1. So that will be 1, and then we're going to subtract our exponents and making sure that the base are the same. So I'm going to subtract the exponent of our base x first. So 3 minus 1 will give us 2. And then the y, 3 minus 1 is also 2. And then here, 45 divided by 5 is going to be 9. And I'll copy the operation addition. So that's 9. And then x, 2 minus 1 is 1. So I'm just going to put x. Or let me just put the invisible 1 there. And then y, 2 minus 1 also is 1. And then finally, the last term, we got 30 divided by 5 is going to be equal to 6. And then x, so 1 minus 1 is 0. And remember, any number or any base raised to the 0 power is equivalent to 1. So if that would turn out to be 1, and then this one is also 1. Or you can just disregard that because it's already 1. So remember, any number raised to the 0 is equal to 1. So don't be confused on that. So the other factor that we're looking for is x squared. I'm just going to disregard the 1. I'm going to make them invisible. So x squared, y squared, plus 9xy plus 6. So this is the other factor that we're looking for. The other one is the 5xy, the GCF. So this is the answer that we're looking for. If you want to check your answer, you can distribute the 5xy to the x squared times y squared plus 9xy plus 6, and the result is going to be the original polynomial that we have. So here's another example. We got 6x to the third, y to the third, plus 18x squared, y squared, plus 42xy. So to find the GCF, we're looking for a number that can evenly divide the coefficient first, which is 6, 18, and 42. And we found out that that's going to be 6. And then find also the GCF of the variables. For the x, the lowest degree is 1, so that will be just x. And then for the y, the lowest degree is also 1, so that will be y. So therefore our GCF is 6 times xy. So this whole expression right here will evenly divide the polynomial that is given to us. So this will count as one factor already, and then to find the other factor, we're going to use the GCF to divide on each term. So I'm going to divide 6x to the third y to the third by 6xy. So we know that this is going to be 6 divided by 6 is 1, then 3 minus 1 is 2, so x to the second, then 3 minus 1 is to the second power, so that's also y squared, and then plus 18 x squared y squared divided by the same GCF, which is 6xy. So that will be 18 divided by 6 is going to be 3, so plus 3, and then 2 minus 1 for the x is 1, and 2 minus 1 for the y is 1, so y to the first. And then lastly, we also have plus 42 xy divided by 6xy, so 42 divided by 6 will give us 7, and then x 1 minus 1 is 0, so that turns out to be 1, and then y to the first and y to the first, that's 1 minus 1 is 0, so that's also 1, so I'm not going to write it anymore. So the other factor that we're looking for is this guy right here, and then put them together, the GCF and the factor, and this is what we're looking for. So if you want to check your answer, you can use the distributive property, and the result should be the original polynomials that we have. Now, how do we factor trinomials with leading coefficient equals to 1? So when we say leading coefficient equal to 1, that means if we have a trinomial in the form of ax squared plus bx plus c, when a is equal to 1, that means that leading coefficient, that right there, a is equal to 1, we are going to automatically create two sets of parentheses and put the factors of x squared in the first position of each set of parentheses. And then the second positions are the factors of c that add to b. For example, we got x squared plus 8x plus 12. So we're going to start with doing the parentheses, and I'll find the factors of 12 and 8 that will add up to 8, paying attention to the signs. Since both are positive, you can add the signs next. Then find the factors of 12 that when added together will make 8. And we found out that the factors 12 times 6 equals 12, and add up to 8, leaving you with x plus 2 and x plus 6. Now let's take an example. So for example, we have this trinomial. So first we have to identify our a, b, and c. It will help us think of those numbers. So for this one, the a is equal to 1. There's an invisible one there, right? For the b, that's going to be 15. And for the c, that's going to be 54. So according to the previous slide, when we are factoring trinomials, we get 3 terms, and the leading coefficient is 1, automatically create that 2 open parentheses, and since our variable is x, so we put x on both to start with. And now we're going to think about factors of 54 that can add up, that when we multiply is going to be equal to 54, and when we add is going to be 15. So I'm thinking about 6 and 9. 6 and 9 when we multiply is going to be 54. 6 times 9 is 54. And 6 plus 9 is going to be 15, which is the b, which is right here, the one that we're looking for. So in that case, because this is addition, so we can just put add. We must also pay attention to those signs. If it is addition, we can just put addition there. and then just put the two numbers that we thought of that would multiply to 54 and add up to 15, which is the b. Now let's take a look at this example. We are given x squared plus 2x minus 3. The a is equal to 1, so the leading coefficient is 1. The b is equal to 2, and the c is equal to negative 63. So now we are going to pay attention at this guy right here, which is negative 63. Let's think of a number that when we multiply together will give us negative 63. So I would say 7 times 9, right? 7 times 9 is 63. But when we add this 2, this will give us 16. But we're looking for that when we add will give us 2. So that means one of them must be negative. So when we are deciding who's going to be negative and who's going to be positive, try to consider the sign of the second term, which is in this case positive. And whatever the sign of the second term, that sign will go to the highest number. So the highest number, the highest factor that we have is 9. And since that's positive on the second term, so the 9 would be positive, and this should be negative. So if we multiply negative 7 times 9 will give us negative 63. And if we add negative 7 plus 9 will give us positive 2. And this is exactly what we're looking for. We want a negative 63 and a positive 2 in the middle. So therefore, writing your factors using the two open parentheses, open and close parentheses, you put the x on each, and then you can just put the negative 7 and positive 9. If you put positive 9 first and then negative 7 next, that's okay. It can be interchanged because it's multiplication. Now, what about if a is not equal to 1? So as you can see here in this example, we have 5x to the second plus 7x minus 6. As you can see, your a is not equal to 1. This time your a is equal to 5. Your b is 7. And your c is negative 6. So if your a is not equal to 1, there will be additional step. We can use the groupings, but I decided to show you a different method that would be easier to remember, hopefully, because grouping can be more complex. So now, if that's the case, if your a is not equal to 1, what you're going to do, the first step is multiply your leading coefficient. I'm going to put here leading coefficient and the last term. So times the last term. So that being said, your leading coefficient is 5. Multiply it to the last term, which is negative 6. So that would be negative 30. Next, you can drop the leading coefficient. Then use the result for from number 1, from step number 1. So as the constant. So that being said, we'll drop the leading coefficient, so I'll have x squared only, and then plus 7x. And now we'll use the result from number 1, from step number 1, as our constant. Now we have a new trinomial, x squared plus 7x minus 30. the next thing to do is try to factor it. So factor the x squared plus 7x minus 30. So you'll apply what you learned in the previous slide. So think about of two numbers that will multiply to 30 but will add up to positive 7. So think about those two factors. So I'm thinking about 10 and 3. Okay, so if we use 10 and 3, before we assign the sign, who's going to be the negative and who's going to be the positive, I'm going to consider the sign in the middle, which is positive, and this positive will go to the higher factor. So the higher factor is 10, so that means the 3 must be negative. So our factor would be x plus 10 and x minus 3. The last step, I'm going to write it here on the other side. I'm going to change the ink so that you can see it. Change it to yellow. So the last step, I'm going to put the step right here, step 4. Using the factors that you thought of, we got x plus 10 and x minus 3. This is the time that you're going to bring back the 5, the a, the value of a, and divide it to our constant on each term. So I'm going to divide the value of a to the 10 and to the negative 3. Now if you can simplify it, that's very good. So you can simplify it. So this becomes x plus 2. And then in this case, 3 divided by 5, negative 3 divided by 5 does not work. So what we will do is to bring that denominator in front of your x. So that will be 5x minus 3. So this is what we're looking for. This factor x plus 2 and 5x minus 3. When you multiply this together using FOIL method or the distributive method, your answer must be the original factor. Now again, for your next steps, you can start your Alta assignment, or you can do some more practice. I would advise to, if you didn't get the last topic, which is factoring when a is not equal to 1, I suggest to go back to that portion of the video and please take down notes if it is necessary. Okay, thank you for listening, and I'll see you.